Well, good afternoon, everybody. My name is Shane Hawthorne. I'm from Amazon Web Services Region Services Division. We're actually the division that does a lot of work on what are called the air-gapped regions in the commercial cloud service. But what I'm here to talk to you about today is a really interesting new service that I'm actually the general manager for. The name of this service is AWS Ground Station. And like I said, I'm Shane Hawthorne. I'm the general manager of that program. And wanted to, first off, start out this talk by saying, even though I'll be honest with you, it's very hard to see into the crowd because of the glare of the lights. How many folks here actually work with satellites, space operations, or ground stations, or have before in the past? Okay, so that's a good norming thing there. This will be interesting, and I'm going to really be trying to talk to you guys in a way so that everybody can sort of get and understand how they could capitalize on AWS Ground Station and use it in their businesses and in your applications. And just to give you a little bit of a heads up on how I would like to run the show as well, I'm going to leave a little bit of time at the end so that we can have a couple of questions and answers in case people were interested in how the service actually works. So thank you all for coming. So a little background. I've been at Amazon Web Services for about 2 years. And actually about 1 3/4, almost to the 2-year mark. Before that, I actually worked in the US government, in the Air Force, as well as in a company called the MITRE Corporation, where I did a whole lot of different things with satellites. I've done ground station operations. I've worked on launch vehicles. I've integrated satellites onto launch vehicles and built satellites and launched them into orbit. So this is a project that is incredibly passionate to me. I own this entire service, working for Region Services to deliver it to you. And it's like been my life for the last year. So really excited that you guys are here. So first off, what is a ground station? A ground station is basically a surface-based antenna system that is put into the ground so that you can allow satellites to communicate with the Earth. And typically you use that service so that you're able to communicate with the satellite just like you would do with hardware or infrastructure. You want to monitor the satellite's state of health. You're going to be checking on it, making sure that it's executing its commands properly, watching for anomalies. That data all comes down to your ground station, and then you monitor it and you keep track of the satellite's health. If you need to change things, for example, maybe one of your solar arrays motors aren't working or something like that, you need to point it at the sun better, you change over to an alternate motor. That would be a command that you uplinked to the satellite. Now, if you had satellites that were actually taking photos of the Earth or something like that, you would also be sending commands up to that satellite to tell it what you wanted to do in temporal space. So you tell it, hey, at this time, as you're over this part of the Earth, I want you to take a picture of here. Those are all the uplinks that go up to the ground stations. And then the last thing that the ground station does coming down to it is the product or the payload data, the mission data that the satellite collects that a company actually wants to make money off of, sharing with others, making decisions from. That mission download comes into these ground station antennas as well. So you have to have the ability to uplink commands and downlink the health of the satellite and downlink that mission data. That allows you to do your mission with the satellite. So location is a real key driver of where you put ground stations, and it can present a lot of challenges to our users. So the reason why that's such an important issue is if you have a number of satellites in what's called a sun-synchronous or a polar orbit, that means that they tend to go over the Earth's poles. And there's a couple of different reasons for observing the Earth that you do that, but that results in the fact that those types of satellites usually like to have their ground stations up at the top of the Earth because they go over them a lot, and that allows them to communicate many times in a day. Other satellites that are maybe orbiting around the equator of the Earth, in the mid-latitudes of the Earth, they would like their ground stations to be in those latitudes of the Earth because that way they could go over them, and they have frequent opportunities to download the data. That's what we we mean about accessibility. Can the satellite get to that ground station? Or can that ground station make a link with the satellite? And then availability. Do you have enough ground stations to take care of all the satellites that you're actually using? So the location drives both of those. Because if you're in the pole, you need a lot more antennas because a lot of the satellites are going to go over the poles of the Earth at the same time. Availability is difficult in that case. So, ground station market situation, it's just like Andy was talking about yesterday during our launch, which I hope a number of you guys were able to see. Basically, we'd been listening to our customers, and they were being presented with a number of challenges, and they had come up with ideas of, you know, if you were able to use the AWS network with our really robust regions and availability zones and the way that we build everything around the Earth to give strong reliability and resiliency even to operations, it's kind of a perfectly made situation to help address some of these challenges. So the challenges that these customers wanted us to help them fix with AWS Ground Station was, first off, a lot of times if you build your own satellite, you're thinking of a new mission, you're faced with, I'm going to have to maybe consider that I have to build my own entire ground network. So that means I'm going to have to go through the work of finding the land for these antennas, locating where the antennas should go, making sure that I have good sight angles and visibility around the entire ground station location so that I can see these satellites as they're coming up over the horizon. And it's not like I put it over here in the middle of the Venetian and it's covered by buildings and I can't see the satellite except for when it's directly over my head. So they end up having to do all this work to find the ground station, buy the land, put the ground stations into that area, and then comes the building of the antenna itself. They're expensive. They often need a lot of different workloads and business process logic in order to make them work. You have to provide the infrastructure. They need to be connected to the network. And you have to operate them and maintain them and sustain them. So building your own ground station could be a real heavy lift, especially if you're only thinking about a 2 to 5 satellite, maybe demonstration project where you want to develop an idea and maybe get venture capitalists interested in your new project. And you don't want to sink all of this money into a ground station network at the beginning. The other alternative that creates a challenge for these customers is the need to maybe lease these ground stations. And what that means is there's a number of great places around the world who offer antennas as a service, but not as a web service, where you can come in and you can actually lease or rent time on the antenna. But that also brings a strong tail of sustainment and logistics that you have to take care of, where you have to install your own hardware. You have to pay for the time that you actually use the satellite, and you oftentimes have to pay for a long-term contract in order to get the prices that you want. So you're sort of bought in strongly at that point, and that can also limit a company. In addition to that, in a typical scalability situation, satellites are also faced with the need to maintain enough ground stations and enough downlink capability to take care of peak periods of operation. When they might really be busy, they're taking lots of images, for example, after a hurricane or fires or to support certain news events. Suddenly, they've got to get a lot of data down, so they need to make sure that they have enough ground stations to do that. But for during normal operations, they might end up being in a situation where they're only using their ground stations to 30, 40% utilization, and all that other time it's not being used. And they're paying for that, and they're operating it and sustaining it. That is a key challenge. Another one is satellite scheduling. Once you get into kind of a contention situation, you might be using ground stations that a lot of other people are using, or you've kind of built your own, so you're trying to have the bare minimum that you can do to take care of your peak. Well, if you have the situation where a number of your satellites come over these ground stations at the same time, they can actually start to interact with each other or interfere with each other's ability to downlink data at the same time. So that's what we mean by you can have a challenge in scheduling your satellites. And then finally, and one of the things that we're really excited about AWS Ground Station offering to meet these challenges is you oftentimes don't have compute and storage or the ability to apply cloud services or AWS services to your data the moment it comes off of the satellite. And this is something that a lot of our customers want, because It's all about speed today. Everybody wants to collect data. They want to task their satellites to find things, and they want to get that data back on the ground as rapidly as they can, because that allows them to get their product to market quicker, and they're able to monetize and keep on producing things that their customers want. So these challenges summed up from a customer point of view, if you look at the point of view of government customers whom we want to be able to provide services to, and then education from the point of view of universities or university-affiliated research centers, all the way down to high schools, putting up shoebox satellites. All of these people are putting small satellites up into orbit today. And then we have businesses out there who are strong players in the market today. There's a number of Earth imagery systems. For example, a good partner of ours is Digital Globe. We've been working with Black Sky, and we've been working with Capella. And these are different satellite systems that want to take pictures of or image the Earth with different types of phenomenology, like radars or optical systems like our cameras, or different frequencies like a Digital Globe can actually see in infrared so that it can see fires through clouds. So those customers want to get their data to the ground. And so they have the challenge that the ground, like I told you, is expensive to build and maintain. It can require some very high capital expenditure, and so as a result, that CapEx is required to go into their ground station network, and they don't get to use that to build satellites or build payloads or instruments or sensors that are monitoring the Earth to make money for them and help them to keep their business going. That CapEx can now be traded for variable expense. Now they can use AWS Ground Station and maybe save that CapEx to do other things, or just save the money completely. Also, in today's day, the challenge from some of these distributed ground networks, because of those locations I told you about, which can be remote and austere, they end up having latency, and it can take a little bit longer to get that data back to their processing center or to the cloud than they would like it to. By putting our AWS Ground Station antennas in close proximity to our data centers, that enables them to have very low latency from receiving the data into the antenna, using digital signal processing equipment to actually demodulate it the same way the modem does behind your TV at home to get your cable signal and turn it into internet, and then allow you to get that data into AWS so that you can actually start using our services and features on that information. The latency can be very low, and we're also going to provide capacity on demand to meet our customers' needs. So by allowing customers to reserve time ahead of time on the system and schedule minutes of contact for the satellites, that'll allow us to start planning capacity, and we're actually building antennas ahead of time, and we're actually building our ground stations with expansion in mind, so that as we grow our customer base and as their needs increase, we'll be delivering a very high level of SLA so that we can not have conflicts while they're operating. And then finally, in a typical AWS fashion, AWS Ground Station is going to have transparent pricing in order to address the challenges of opaque pricing, which we see in the market a lot today, where when people go to lease or go to buy, they're not sharing that data. You don't typically have the economies of scale of buying all the equipment. And as a result, you really don't know what the market price is typically, and you are thus a little bit at a disadvantage. With this system, you're actually going to be able to look on a console, and you'll be able to see the price, and you can plan for it, and you can use the same types of calculators that you use for your other AWS services to compute out how much you're going to pay to use our service as well. So the customers told us that they had some strong requirements in addition to the challenges that they wanted us to meet for them. These requirements were, first, that they didn't want a CapEx commitment. They wanted to be able to come in on demand and be able to use us and scale us as required. And that's a really interesting thing for a lot of satellite and space customers, because by allowing them to have on-demand scalability, they can now plan for a system with, say, 60 satellites, but they know that they're going to put up 3 or 4 demonstrator satellites at the beginning of their program's life. And they don't want to go, they're going to have to build a complete ground station network for those 4 satellites, but they want to learn something from those satellites. So they're going to put up the first 4, they're going to experiment, and then while they're building the next 56 of those satellites, the ground stations are sort of sitting there fallow, waiting to do something, being maintained, costing them money. In our world, they're going to be able, their requirement was, we want you to make this on-demand and scalable the same way that we can get EC2. They also said, had a strong requirement for minimal data latency, actually into the realm of milliseconds of time between receiving data on the antenna and being able to get that data into our VPC so that we could then stream it into the customer's VPC. They told us they wanted direct access to the data center so that they could apply AWS services to their data. That gives a lot of opportunities to a satellite customer. You can apply machine learning. You can apply things like recognition for doing pattern matching and looking at the images. You can do lots of different types of new algorithms that you can try out. And then if you don't like them, you can modify them, and they're not built in and deployed around the world. They're in the cloud. And then finally, they wanted, like I told you earlier, simple and transparent pricing. So, as Andy launched yesterday, we listened to our customers. We listened to their challenges and the requirements that they wanted us to provide, and we've created an offering in preview mode right now, AWS Ground Station. And what AWS Ground Station is a fully managed, self-service, global ground station as a service, which we also, you'll hear many people call GSaaS, or Ground Station as a Service. And that's going to give our customers the ability to easily and effectively control their satellites by uplinking commands and monitoring their data in the cloud. It's going to allow them to downlink and ingest that data in AWS, and it's going to allow them to process that data right there in AWS Cloud. And that is going to enable them to innovate and share their data with a number of other collaborators and customers, and then use AWS services to take care of processing that information. So let me give you a little overview now of how AWS Ground Station will work. First off, we got the customers that I told you about earlier, the government, the higher education, and businesses. They're now going to have no ground station infrastructure commitments. You'll be able to log on to the AWS console. It's open today. It was launched yesterday when we made the announcement. And we'll have an onboarding process for how we bring people in to come and get their accounts so that they can actually operate satellites. And we do that on purpose because we want to provide assurance to satellite operators that we're not just letting anybody walk in and start trying to communicate with their satellite. It's the same way you would feel if someone was driving down the road of your neighborhood and was trying to see if their garage door opener would work on your garage door. You don't want somebody to be seen if they can communicate with your satellite at the same time. So as part of our onboarding process, as you go to the console, you're actually going to go through a simple 2-factor verification process where we'll look at data and we'll work with you so that we can validate that the right people want to communicate with the right satellites. And then they'll be able to get in, and you're going to either be able to literally reserve minutes on demand, which means at that point in time you could actually schedule the next available contact after you've figured out if the satellite is going to be in view of a specific ground station, or it's going to give you the ability to reserve minutes for a long period into the future so that you can get a discount on reserved minutes the same way that with EC2 you could get a discount with reserved instances. So it's going to give a level of flexibility in planning so that we can manage our capacity, and it'll benefit the customer because you'll be able to find lower cost per minute for your uplinks and downlinks by using a reserved minute model. So it'll be usage based. You'll pay per minute instead of per data, which is really neat because that means a lot of the satellites of today are getting bigger. They're collecting more data. They're downlinking more data. We want that data to come to AWS. We want you to be able to use our services to process it and make it better. So we wanted to make it a per minute charge so that you could take advantage of that and not be limited by your data rate or your bandwidth and trying to cut it down. We want you to make it as big as your mission requires. And then we're going to provide you self-service scheduling. This is kind of an important facet to go into. There's a number of great programs, there's a number of great satellite systems around the world that do what's called mission planning. And mission planning is when you'll figure out what you want to do with your satellite. For example, I want to take pictures of the forest fires in California. So you need to plan that. I know when my satellites are going to be over these parts of the Earth. I know that I want to take photos at certain times, certain places, and then I know where the ground stations are so that I can command the satellite and I can downlink data. That's mission planning. We want to help foster a strong marketplace and a community where people build mission planning, they build satellite processing, modems, software definable radio applications on AWS to do all of those functions. And we're going to be providing what we consider a simple reservation service, where your mission planning system could interact with AWS Ground Station via APIs, and then be able to, in a machine-to-machine manner, schedule the time that your mission planning system told you that you needed to do certain activities on your spacecraft. That way, you can control those aspects of your satellite, and we can be providing you the scheduled contact times that you need to meet your satellite's needs. We're also going to have the ability for simpler, smaller satellite systems to simply use our manual GUI console, go into the AWS console, navigate yourself down to the new space and satellite. I'm just trying to think of the right word here for you, but the category, so that that's where AWS Ground Station will be located. And then you could simply go to our console and you'd be able to log in, and once you'd been onboarded the first time, you'll be able to schedule things manually right there on the AWS console. And by doing this, we're going to have 12 ground stations that'll be located in close proximity to our data centers around the world, and that'll give you that global reach and latitude dispersion as well that we talked about earlier, so that we're able to put the satellites, ground station contacts that you want into parts of the Earth that you can get. And like I said, you'll get the reliability, you'll get the redundancy and the resiliency of the AWS regions and availability zones with these antennas, because they're built close to the same places, so they get to take advantage of that architecture. Finally, you're going to have direct access to AWS services, our infrastructure. The network and the backbone that ties all of our regions together is going to be provided as part of AWS Ground Station, so that you can move your data around. And another key facet about our overview that's important is you're going to be able to have a account on one region, and you'll actually be able to access the ground stations in other regions from that one account. It's a global service that we're providing with AWS Ground Station, so that you're actually able to get your data back to one place and operate from one place. So some of the key benefits that I just would like to foot stomp after talking about that is, first and foremost, it's going to allow you to innovate with AWS services. So there's a lot of different kinds of use cases that you can get into with that. I'm going to talk about them in just a little bit. But just start thinking about how you could orchestrate all of our services together to process data, bring data down from the satellite, share it with other customers, make decisions, and then distribute it as a product over AWS. You're also going to be able to save up to 80% on your ground station costs over building your own ground station network that would provide a comparable level of capability. We're building a really good network. We've got 5.4 meter antennas, full motion, so they can actually track any satellite all the way down to the lowest low Earth orbit orbital velocity. And then you're able to download that data and process it with state-of-the-art digital signal processing equipment. I'll talk about the whole architecture in a couple of slides, but it all comes together to provide a really first-rate system that will really give a lot of capabilities to our customers at a significantly lower cost, since they're only paying for it by the minute. And then finally, it's going to be fully managed by us. We are actually operating these antennas. We're keeping them safe. We're watching them all the time. We're the people who, my team actually are the people who respond to any tickets that have to do anything. If we ever had a drive go down or anything, which is going to happen very rarely, quite frankly, because we're really buying such good antennas, we'll be able to fix them almost immediately, because we built everything into our own network and our own infrastructure. So some key features, as I've talked about earlier, you're going to be able to control your satellites, command and control, or as many people call it in the industry, TT&C, tracking, telemetry, and control. And you're going to be able to schedule off of the API or off of our GUI console. You're going to be able to uplink and downlink data, both narrowband data, which if you want to think about it this way, a good way to think comparatively is narrowband data, which is about 54 megahertz of bandwidth, is like 4G. And then you can do wideband data, which is up to about a gigabit per second or a gigahertz of bandwidth, is like 5G. So we provide 2 levels of data rate in order to meet the needs of different types of customers. And then you're going to be able to pay per use, and you're going to get that low latency, rapid data processing that I talked about with you earlier. So how do we do it? This is the cool thing. We've been working on this for a while. Our software development team and our hardware team has been building the ground stations. I'll start from your left-hand side, which is the satellite needs to talk to the ground station or needs to be talked to by the ground station. In close proximity to our regions, you're going to actually have our antenna systems. At each of our ground stations, we'll have, as a start, 2 antennas. And we're doing that on purpose so that we have some redundancy and some reliability. And we're going to keep on staying ahead of the customer's needs and adding more antennas around the world as we build out the AWS Ground Station system. We're starting out at preview with only 2 ground stations, one in Ohio and one in Oregon, and we're currently building all of our other ground stations right now for the next year's rollout so that we can get our the next 10 ground stations out in mid-2019. In the AWS Ground Station VPC, you're going to have all the functionality that we use to operate and run AWS Ground Station for you, the customer. You're going to have the onboarding functionality that I talked about earlier, going in through the console, and then a method of communicating back and forth with you so that you can get through the onboard process. And then you have to have a significant amount of orchestration that goes into the system to orchestrate the software services that are interacting with the components of the antennas and the digital signal processing equipment so that we can actually configure the ground station to fit each satellite operator's configuration for each of their contacts. So we have to be able to do that very rapidly so that we can do a contact with one satellite and then in a minute or 2 after that reconfigure the ground station, point the antennas in the right place for the next satellite to come up, and then be able to take care of them as well. Because as I told you, we really want to be able to provide a low contention or no contention service to our customers. So orchestration has been key, and it's been a lot of work. Now, if you're going to run any kind of orbital system communicating with satellites, you have to have a good orbital propagation capability. You need to know where the satellites are. You need to give our customers the ability to load what we call ephemeris or satellite location data into the system so that we can predict where you're going to be and tell you if the satellite is going to be in view of a ground station so that you can make a good reservation and you can feel comfortable and guaranteed that you're going to be able to talk to the satellite when you planned on it. That's the realm of the propagation and location sync services. And then after that, you're now kind of in the realm of receiving the data from the satellite. That's why I would point you to the bottom 3 right-hand side of the satellite VPC. First off, the scheduler has now told you where you could talk to your satellite based on orbital mechanics and where your satellite is. You made a reservation, it goes into the scheduling system, and now we know that you actually have this slot. When the satellite comes above the horizon, we'll actually be waiting for it, and we'll be waiting to receive the data as the satellite starts to try to communicate with the ground station. That's when we actually have a narrow band or a wide band, as I told you, a high data rate or a low data rate capability to downlink that data into a software-defined radio and receiver. And then we also have software-controlled modems in the pedestal of each of our ground station antennas so that we can actually configure the receiver and the modems to be exactly like the hardware that you built your satellite to work with. And so in that case, you're then able to demodulate the data, decode it, frame sync it, make it work the way that you're used to it working with your own system, and you can then pass it into a front-end processor. And the front-end processor is basically what can take the raw data and turn that into objects and files that you use to make information from for your system so that you're able to then turn those into the things that you're actually trying to collect data for. So the raw data from the satellite sensors now becomes either radio frequency intercepts of figuring out where a signal is and where it was going and what angle it was pointed at, or taking pictures of the Earth. You're turning that data into an actual image that people are used to looking at. Or you can get into more esoteric things like radar data or multispectral data, where you actually can analyze pixel by pixel what you're looking at. The front-end processor is what then delivers that data to you in a usable format. Another neat thing that our software-definable radios and modems can do is we actually can configure them as well to act as what's called a digitizer. The digitizer allows you to give yourself an even higher level of surety that the data that we took off of the satellite is as close to the original data as possible by leaving it in an analog form that can travel over an IP network. So we do that by putting the data into what's called VIDA49, which is a standard for radio frequency or RF data over IP. And we have the ability to now allow you, once we reach general availability, to send that data over the IP network back to the region where you're actually processing your data, and you could store it and you could leave it in RF. You could even connect it to another digitizer and convert it back into analog data if you wanted to process your data in analog. So it gives you a good amount of flexibility to process your data. You can either put it out in what's called baseband, which is a very low, relatively speaking, it's a little bit of data that you don't have to work as hard to move around the network, or you can leave it in RF over IP, which is a very big amount of data, but it gives you the level of fidelity that a lot of customers want. Now that data then goes into the customer's VPC. We can actually stream it into the customer's VPC, and now the customer has two options. If you used our VPC to do the demodulation and the receiving and the processing, and then went through the front-end processor to turn it into baseband, you could simply move that data now into your VPC and start saving it into S3 buckets or EBS, or you could even start processing it right there in your VPC. Literally a millisecond or a second after it came off of the antenna, you can start making things with your data in the region where the data landed. Or you could then move it across the network to wherever you are, and you could do the same thing. Or if you wanted to leave it in RF over IP, like I talked about earlier, you can now have your customer VPC full of your own, bring your own capabilities. You could write your own modems. You could write your own software-definable radios. You could write your own front-end processors, or you could run front-end processors from a number of our collaborating partners who are going to be putting services out there into AWS Marketplace to offer modems and offer software receivers that you could buy or use by the minute and put into your VPC to process data. And then in addition, you could have your own monitor and control system that's monitoring the telemetry and the data coming off of our system so that you can see what's happening while you're working with your satellite. And you can monitor your own system, you can run your satellite, and you can have command and control software so that you can literally write your commands and send them back up to the satellite from your VPC during the contact. And to prove that this actually works, we've actually done this. If you guys go out and look at Digital Globe's blog, they actually have a really cool example of where during one of our test cases, we were actually able to command a satellite from the ground station region where it was coming down in Oregon to take a picture of the antennas where we were working and testing with Digital Globe. People posed out there in the form of an Amazon smile. And then after the satellite took the picture, they ran back into the control area of the data center to see if the data had come through. And by the time they got to the data center, the data had already been downloaded, had already been processed, and was already sitting in an S3 bucket before they got back to the data center's conference room, which was only like 100 yards away. So it just really showed that you're actually able to downlink data, get it into an S3 bucket where you could do something with it in less than a minute with a system like this. And it's all on the cloud, so you could do it from anywhere in the world. You don't have to do it just, at your ground station or at your operations center. And very important to note, all of this functionality and capability is put on top of AWS's security and identity. We're managing your guys' access and anybody else's access so that you can know that your satellite is secure, your command and control activities are secure, your data is secure, so that we're able to protect the information and keep you guys operating. So, what are some of the AWS services and ways that you could use AWS to function with the data that's coming off of your satellite? Obviously, you're going to be able to use EC2. Our system is like completely using EC2 to run processes, all the things I showed you in the VPC earlier. And then you are going to be able to build your own monitoring and control types of software. You'll be able to build your own modems. You could actually build mission processing. You could analyze your data, all on EC2. And now the cool thing about it is you could build your satellite. You can test it with EC2. You can keep on modifying and improving your system, and it's all running on EC2. When you're not doing anything with the satellites, you're not paying for it. And now you can use the same thing to test that you can use when you're on the satellite's launch vehicle. You can actually verify everything's functioning before you take off. And then once you get into orbit, you can use the same stuff again to communicate with it in the ground station that's connected to AWS. So it'll give you the ability to do everything from the cloud, and you'll be able to use the same software and feel secure with it because you're not transferring it to different places, different systems. You're able to just use the same things you've been using for the whole development of your satellite. You're also going to get things like Amazon recognition for real-time satellite analysis. Say you're taking pictures of the Earth, and you're a satellite that's not working with IR, so you care about the fact that maybe there's a bunch of clouds covering what you wanted to image. You could actually do a real-time look at that data as soon as it came off into your VPC. You could discover that the cloud cover was higher than the level that you like for your operations. You could send a command back up to the system to tell it to take a picture of that area again. And you could do a lot of functionality like that. You could also use SageMaker to build custom machine learning applications so that you could actually start to make decisions from some of the data that was streaming into your VPC. That can open up a lot of really cool use cases as well. And what I'm really excited about with that is that I'm a space guy. I come to this with a space guy bias. So I kind of think of the way that I've always done it or the way we've done it. I'm really excited that we're going to get a lot of innovative thinkers, people who are going to be able to use space data for new things that have never been thought of before. And they might start thinking about combining data and using ML to make decisions and inferences from it that, quite frankly, a lot of us have never thought of, and it might become the next big thing from the point of view of using space data. And so we're going to be able to give that kind of a service there for you. You're also going to be able to use a gateway connectivity from Amazon's VPCs. You'll be secure inside of there, and you're going to be able to store your data in Amazon Redshift, or as like we were talking about earlier, S3, many other ways that you'll be able to take good care of your data. Now, I did want to make sure that I was clear, because as I talk about how cool AWS Ground Station is, and I think you could probably tell I'm kind of in love with this service, I'm very passionate about it, is that I want to make sure you know what I could do for you today and what our service can do for you today and what's coming in general availability in mid-2019. So today for our preview launch, we're able to support low Earth orbit and medium Earth orbit satellites. And I wouldn't get into worrying about what range I mean, because what I really mean by LEO and MEO satellites is just that we have antennas that are fast enough and are able to focus on any point in the horizon such that we can support any kind of orbit. Geosynchronous orbit, like what your Dish TV uses or things like that, that's a very easy type of antenna to do. It's actually harder to keep up with the LEO satellites and the MEO satellites because they're very fast. If you guys have ever watched iridium flares when you're out there in your back deck or something at night, you can see how quickly a satellite will move across the night sky. You have to have an antenna that can do that as well. And so these antennas are fast enough to do that. From a supported frequency point of view, we're going to be able to simultaneously downlink in narrowband, S-band, X-band, and UHF frequencies. We purposely are starting with downlink because downlink is a capability that customers can use and take advantage of very quickly and legally, because you can actually change your license, you can downlink data to us very rapidly, and legally we're allowed to receive that. When you start to transmit up to satellites, it can take a little bit longer for a satellite operator to get permission from their regulatory authorities. And so we wanted to give downlink first because that would allow people to take advantage of us more rapidly. So with a narrow band, S-band, X-band, or UHF band capability, anybody's satellites who are downlinking telemetry data and command and control data in those frequencies should be able to take advantage of playing with us and testing with us on AWS Ground Station during preview. And we'll be able to get that data into your VPC so that you can look at that information as long as it's narrow band data and it's in these frequency bands. And like I said, S-band, these frequencies are going to be coming down in both Oregon and Ohio. And these little orange rings that I've got drawn about those are actually the access out to about 2,000 kilometers that you can get with all of the LEO orbit satellites. So it kind of shows you how far these antennas can reach out and touch the satellites and actually receive data from them and communicate with them. Now, at general availability in 2019, we're going to still be focused on LEO and MEO satellite systems, but bigger and better things will be coming in future services. And then we're going to be supporting narrowband and wideband X-band downlink, and we're going to be supporting simultaneous narrowband, S-band, and UHF uplink and downlink, all with the same antenna at the same time. So some satellites, they like to command with UHF. Other satellites like to command with S-band. And then most satellites like to downlink most of their really big data sets with X-band. You can actually do all of them at the same time with this one antenna. And it'll all stream into your VPC at the same time. And you're able to stream your commands up to your satellite at the same time. And it's all part of that one price. So it's going to give a lot of capability to our customers. We're very excited about it. And we're going to be rolling this out, like I said, into close proximity of 12 of our regions around the world. And I want to highlight, that's counting Oregon and Ohio. So once we get done, we'll have 12 complete sites. So what are some of those use cases I could tell you about? One really good use case is, as I've alluded to in a couple of my comments already, the forest fires in California. There's a number of uses for imagery data and, believe it or not, RF data, radar data in forest fires, because radars can see through clouds, infrared, like Digital Globe has, can see through clouds, and you can actually watch the fire, and you can provide this very real-time, very important data to first responders. So the firefighters who are out there trying to beat the fire and also need to worry about the fire enveloping them or encircling them and cutting off escape, they need to be provided warnings about where the fire is and as near real time as they can. So having capabilities like this where you can actually command a look, get an image, downlink it really fast, and then stream it to a satellite provider's VPC so that they can then get that information to the firefighters, gives them the ability to take care of these first responders. Same type of thing when you talk about responding to hurricanes, for example, like in Florida, where you can actually use satellite imagery and you can use machine learning to actually look at bridges and determine if bridges are broken or not broken. You can actually do analyses on how many houses are still standing in that area, how many houses are down, so that you can sort of focus your response efforts and take care of the people who've been most badly hurt first. And you can, again, stream that data down, VPC it, you can process it in a VPC, and then you can use AWS to distribute that data to their customers so that they can get the information to them very rapidly. Another really big area of use cases is weather prediction and reporting. We have a number of customers on AWS who've been already using AWS to process weather data and analyze that data and provide warnings to their customers. Now they're actually going to even be able to access the weather data on AWS so that you can, there's two big reasons. One is saving people's lives. You can actually, route ship movement, you can route aircraft and even people on the ground around bad weather, and you can keep them from going through areas of bad turbulence if anyone's like, flown across the Atlantic during a bad experience, you can see how bumpy it is. If you could get real-time data transmitted down all the time so that you could help avoid that, you don't have to then just rely on reporting from plane to plane about staying away from areas. These systems are now going to be able to receive that data. The other reason it's really good is it helps efficiency in logistics. If you can avoid bad weather and you can go around it, it might actually be a little bit of a longer route, but you could actually speed yourself up and get your product to where it needs to go quicker because you're getting real-time access to the data about places that you need to avoid. Finally, another really cool use case is analyzing data, for example, in parking lots, where you can use radar data at evening hours or daytime hours. You can use infrared data in those time frames as well. And then during the daytime, you can use imagery data in our visible frequencies that our eyes work in. And you can actually monitor the number of cars in parking lots. And you can see if, hey, is my store getting the amount of traffic that I wanted it? And that might sound like to, normal people like me, I might only own 1 or 2 stores. But if you actually own a chain of malls across the country, that's a lot of data that you want to monitor because you can actually then tell people, here's the peak times in my malls. We're seeing these kinds of traffic. We actually are able to estimate this amount of retail from it. And you can actually inform their decisions on where they put stores, who's going to come to your malls, trends during holidays and non-holidays, things like that. You can also use the same type of data, and a number of people out there are doing this. It's just enabled more when you can get the data faster to monitor things like the levels of the tops of oil tanks or ships and shipping centers coming into harbors. How many ships are waiting to get outside? How many trucks are waiting to get into a brewery company so that they can get loaded up and go back out again? There's lots of business trend assessment that can be done by satellites as well. In the natural disaster response use case that I just talked about, I just wanted to highlight that in that entire use case that I went through, you basically detected information, you commanded and controlled the satellite to get you that data. You used AWS Ground Station to make that use case happen. You processed it in the cloud, and then that way the responders could get out there and do the right thing, and you could keep feeding them updates. Likewise, that prediction that I told you about, this is just a case because you're going to be able to see these slides out on the internet after we're done with today's session, and you'll be able to access them on the console. It just gives the exact same run through of how the use case that I talked to you about worked. So AWS Ground Station, in conclusion, is a fully managed global ground station as a service that we're going to allow you to use in a self-service manner, so that you can control it and you can tell it what you want to do, and you can use it to analyze and ingest data, and you can use it to send commands to your spacecraft. So the benefits I just would like to really leave in your mind, just key value proposition for the service is you're not going to have to build ground stations anymore. You're only going to have to pay for what you use. You're going to benefit from self-service scheduling, and you're going to have immediate access to the AWS services that we offer, and it'll continue to improve and evolve at the speed of AWS. So as soon as you get other new services into AWS, you're going to have those services available to process in that region, and you're going to be able to use them to operate on the data that comes off of an AWS Ground Station. And what our hope is for you is that's going to allow you guys to innovate more and get out there and experiment more and build even greater things and do better things in space. So I just wanted to say thank you. I wanted to finish with about 15 minutes or so left so that you guys could get to your next session and actually get a seat. And so if you'd like to ask a couple of questions, feel free. Or otherwise, I thank you for your time, and feel free to press on to your next session. Thank you guys for your time.
Quick question for you, sir. Just a quick question for you. In terms of deconfliction for usage, if you have multiple customers that have multiple birds flying over the zones at the same time, is it the speed of execution that's going to allow you to capture those downlinks while they're flying over the zones of interest? In other words, while they're coming over the vehicle's coming over the antenna? Is that what you're hoping, so that they're not just sitting there staring? And are you going to use, how are you going to handle the deconfliction in that regard? Do you expect a lot of it initially? Or more antennas in tighter areas, multiple antennas at regions and zones, that sort of thing?
We're actually, well, believe it or not, we're actually hoping to do both. in the long term, because you're right, you can actually deconflict by properly scheduling and saying maybe using an optimal amount of time so that you can give a maximum number of customers access at the same time. But then we're also planning to basically, though, provide enough capacity to stay ahead of our customers. So as we're onboarding more customers and we're getting customers to reserve minutes in advance, we'll be able to measure that, and we'll be able to analyze the data, and we'll be able to, because that's one of the beauties of, I'm an astronautical engineer, that's one of the beauties of orbital mechanics is I know where your satellite's going to be. And so I'm able to predict ahead of time and know when I'm going to have contention, and I'm then able to start planning and buying more antennas and putting them into the regions where I know I'm going to have more contention. So we're actually planning to stay ahead of it in both ways. And then in addition, we were thinking big on this. So we want to continue into the future and continue finding additional types of antennas. Like yesterday during our launch, you saw that we're working with the Verge antenna system, and that one of the attributes of the Verge antenna system is that it can actually communicate with multiple satellites at the same time. And we want to keep exploring really cool and innovative technologies like Lockheed Martin's Verge, as well as AWS Ground Station's parabolic reflectors. And in the future, we're hoping that we could get into things like electronically steerable arrays, we could get into Verge, we could get into even laser communications as our customers' needs continue to evolve, and we can stay ahead of what they need. So I hope that answers your question. And if you want to ask more, I'll be out in the hall after this and happy to keep going. Oh, actually, I think he was next, so let me go to him first.
He was next.
He was? Okay, you, sir.
I know that AWS has announced some partnerships with different satellite companies for IoT bandwidth. I believe it was Iridium in particular. Also, there was the announcement at Midnight Madness about Hyber, an IoT startup being selected. I'm wondering if you envision any direct connections between this service and Iridium or Hyber or other IoT things.
Truthfully, the way I'd look at it is there's going to be direct connections between AWS Ground Station and AWS and everybody's space services. So we're actually, I think you're going to see that with customers like that and lots of other customers. We want to provide this functionality to the entire spacefaring community. One of our favorite phrases in our program is that we want to democratize space. So up to today's date, the United States, Europe, China, and Russia, they tended to own the biggest ground station networks around the world. And the rest of the world ends up using a lot of their services to get what they need in the space community. With something like AWS Ground Station, we're actually really excited that every country in the world will now have a 24 antenna plus capability to do ground station communications with their satellites. And it's going to enable two guys in a garage in Zambia the same way as two guys in a garage in Palo Alto to come up with their own satellite ideas and actually get them out there and be able to do it in a low cost, effective way as they build their system out. Yes, sir.
You're also planning on providing orbit determination service using your ASL from your tracking antennas?
We've had a number of customers saying that they would be interested in us providing the ASL data. So we're actually looking at that already as a potential service. So not initially, but you're right. And then we're actually we would consider adding timing clocks to our systems so that you could actually even get much better ranging data and use that to enable you to maintain your orbit and maybe also contribute that out to either the DOC or to the other people maintaining satellite catalogs around the world. Well, on that note, I appreciate everybody's time. I really appreciate your guys' interest. And just thank you for your time and have a great day. Enjoy the rest of reInvent.